Okay, y'all, it's time for pretty much my favorite thing in the whole wide world, which is dividing polynomials using the box. Now, I already knew the box was awesome, but when I found out that you could divide polynomials using the box, I was like, what? Okay, so first of all, it's going to be a little bit weird at first, but I promise once you get the hang of it, it's going to be so quick. And you'll be the envy of all your friends who are doing this thing called long division or synthetic division. It doesn't matter for us. All we're going to do whenever we have division of polynomials is use the box. So the first thing is that we're going to put the denominator, what I'm dividing by, on the side of my box. It doesn't matter. Usually they're going to be binomials. Every once in a while we'll have something bigger than a binomial. But we put that on the side of the box. Now notice I didn't start drawing my actual box. I just drew the side and the top. And that's because sometimes my box is going to change size depending on how my division works out. The next thing we're going to do is put the first term in the first box. So I usually do that and then draw that part of my box, okay? And now what we're going to do is we're going to think about it in terms of multiplication. So I think, what needs to go on the top so that when I multiply by x, I get 3x cubed? In other words, what times x is 3x cubed? Well, that would be a 3x squared. And what you did last night was multiply to get into the box. So now that I know that the top is 3x squared, I can multiply by -1 and get negative 3x squared. So that's how I fill in the first column. Now, we're going to use the fact that our like terms are on the diagonal and think about what needs to go in this next top box. To do that, I need to look at my x squared term in my numerator. I want to have a positive 1x squared, but right now I have a negative 3x squared. So how can I go from a negative 3x squared to a positive 1? I need to add 4x squared. So, like from last night, that would give me 4x squared minus 3x squared is 1x squared, which is what I want. Now, we go back and we think, well, what needs to go on the top so that when I multiply by x, I get 4x squared? Well, that needs to be a 4x. If that is 4x, then I need to multiply by -1, and that would give me a negative 4x. Now I look back at my original problem. In my original problem, my x term was a negative 4x. So, in this problem, I am done. I have a negative 4x, which is what I wanted to end with, and there's nothing else. So this is why I'm saying sometimes we don't need the rest of the box, and I know my OCD ones out there, that's going to really bother you. So you would, you can do this in pencil and erase that, or you can just leave it. So the solution to this problem is that 3x cubed plus x squared minus 4x divided by x minus 1 is equal to 3x squared plus 4x. If you need to, go back and rewatch that example. We're going to do several more though. Here's another way they can write division. Instead of doing the fraction bar, they're just writing a division symbol. It means the same thing. So I'm going to write my binomial of x minus 2 on the left. And then I'm going to look at my first term. So my first term, or my highest term, is x cubed. So I want to ask myself the question, what times x would give me x cubed? Well, that needs to be an x squared. And if the top is x squared, then that means this bottom left box would be negative 2x squared. Now I move to the second term in my polynomial. I want to get to a negative 5x squared. I already have a negative 2x squared, so that means my next box needs to be negative 3x squared. If that is negative 3x squared, then that means that the top needs to be a minus 3. If that's a minus 3x, then I can make this a positive 6x. Now I look at my x term in my original. I have 6x and I want to get to 4x, so that means I need to subtract 2x. If that box is 2x, then I would need the top to be negative 2. And then negative 2 times negative 2 would give me a positive 4. Now, I don't want a positive 4. I want a negative 2. So if I have positive 4 and I want to take away, I want to get to a negative 2, that means I need to take away 6. But notice, I can't multiply something times x and get negative 6. So this is what we call a remainder. So for this one, my answer is not just going to be a polynomial, it's going to be what I have on the top of my box, x squared minus 3x minus 2. But now I need to subtract a 6 over my binomial x minus 2. So it's the top of your box, and then since it's a negative 6, I put minus 6, and you put it over what you were dividing. This is like back in the olden days when you would divide, say, 31 by 10. So that would give you 3, and you would have a remainder of 1. One way you wrote this is 3 plus 1 over 10. Now, they don't really make you do that a lot in school, but you can always write it as your remainder over your divisor. Here's a very verbal way of writing this. If f of x equals blah and g of x equals blah, what is f of x over g of x? Guess what? It's just dividing. And since we are awesome and are using the box, it's just dividing with the box. So I draw my box, or part of my box really. Then I put my g of x, because that's what's in the denominator. I put g of x on the side. And my goal in this problem, is to get to f of x. So I start and I say, okay, my first thing I need is a 2x cubed. How can I get 2x cubed by multiplying by x? Well, that means I have to have a 2x squared on the top. If I have a 2x squared on the top, then that makes this bottom part a negative 2x squared. Then I move my merry self along. Okay, I have a negative 2x squared, but I want negative 3x squared. So that means I need to go subtract another x squared. If that's going to be a minus x squared, then I need to have a minus x on the top. If I have a minus x on the top, when I multiply, I get a positive x. Moving along. Now I want a positive 4x. I already have a 1x, so that means I need to add a 3x. If that is 3x, then that means on the top I have to have a 3. If that's a 3, then my bottom, needs to be a negative 3. And now I've reached the end. So if I want to get to a positive 5, but I have a negative 3, that means I need to be adding an additional 8. So this means my final answer would be 2x squared minus x plus 3 plus 8 over my divisor, x minus 1. So once again, you're putting your remainder over what you're dividing by, if we have one. Now look at this problem. What's different about this problem? Oh no, we have a 2x plus 1. Do you think that's going to change anything? Not really. Now if we were doing other methods of dividing, it would change things. But since we're awesome and we're using the box, it's not going to change a thing. So I put 2x plus 1. Now my first goal is to get an 8x cubed. So I'm still asking the question, what times 2x gives me 8x cubed? Well, that's going to be a 4x squared. See, was it that painful? No, and if that's a 4x squared, then that means my next part is going to be 4x squared. My next goal is negative 10x squared, but I have 4x squared, so that means I need to take away or subtract 14x squared. If that's a negative 14x squared, then that means the top is a negative 7x. If the top is a negative 7x, when I multiply, I get negative 7x. Now, what I want is to have a negative x. I already have a negative 7x, so that means I need to add 6x. If I'm multiplying to get 6x, then that means in the top I need a 3. And 3 times 1 is 3. But I don't want 3. I want a negative 4. So to go from 3 to negative 4, I need to subtract 7. So this means my final answer here would be 4x squared minus 7x plus 3 minus 7 over our divisor, which was 2x plus 1. Okay, at first this one's going to look like one we've done, but there's a little bit of a twist. So we put our divisor on the side. I start off the same way. I need to put first term in the first box. What times x would give me 2x cubed? That would be a 2x squared. 2x squared times 2 would give me 4x squared. Here's the difference. Do you see an x squared term in your first problem? No, I go straight from an x squared to an x cubed to an x. So what does that mean? It means I need to take away any of the x squareds I have in my box. So if I have 4x squared, I need to take out a 4x squared, because then that would give me on that diagonal 4x squared minus 4x squared is 0x squared, which is what I want for my original problem. And then we just keep going like usual. So that means I would have a negative 4x on the top, which could give me a negative 8x when I multiply. Now, what do I want in my original? Let's see. I want a positive 1x. I have a negative 8x, so this needs to give me 9x, which gives me 9, which gives me 18. Now, I don't want 18. I want negative 3. So I need to take away 21. I have a pretty big remainder on that one. So I get 2x squared minus 4x plus 9 minus 21 over x plus 2. So the trick in this one is when I skip an exponent, then that means I have really a coefficient of 0. So instead of my goal being another number, it's going to be just a 0. So basically you're going to change the sign of what you end up with. So I had a positive 4x squared, so I change it to a minus 4x squared to get that 0. Okay, last one. So this one is different because now I have a trinomial going into a polynomial of 4 terms. But guess what? It's exactly the same. It's just going to be a longer box going down the side. I'm still going to do my divisor on the side. And I start the same way. So I put 15x cubed. And I ask myself, what multiplies to 3x squared to give me 15x cubed? Well, that needs to be a 5 and an x. And then I keep multiplying to go down my column. So this would be negative 10x squared and negative 5x. Now I'm going to move only to my x squared term. So I want to look at this negative x squared. I have a negative 10x squared, so that means I need to add 9x squared. If that top box is going to be 9x squared, then that means I need a 3, and then this would give me minus 6x minus 3. Okay, now, once I've gotten basically to the constant term, this is when we start talking about remainders. So move yourself along, negative 11x. So that means I would need to have a negative 5x. Oh, wait, here we go. So negative 5x plus negative 6x. So that column is good. And then after that, I would have a negative 3, which I also already have. So this one does not have a remainder, and it just equals 5x plus 3. No remainder. Perfect. All right, if you need to go back and look at those examples, feel free to shoot me an email if you have any questions.